Hi. So I picked up this ancient voltmeter on or multimeter on eBay, and obviously with the idea of turning it into a clock. It's got some nice Nixie tubes. They all appear to be working fine. So the initial plan was to really try and reuse the power supply for the Nixies and maybe some of the driver circuitry, and then to insert a typical divider counter type clock circuit inside. And that's fine, loads of people have done that on the internet, I'm sure that would work. But then playing around with this for a bit, I've just connected up to the voltmeter here, it seems there might be a simpler way. So 1208, if I increase the voltage slightly, 1209, 1210, 1211. So you can sort of see that maybe this will work just applying the correct voltage for the time that I want. Now this has multiple ranges. The way these ranges work is when I'm in the 200 range there, you'll see the decimal point moves over. 20 range, it's nicely in the middle. So I've got a nice hours, minutes separation. The one drawback is that on its 20 volt range, I thought I might be able to exceed 20 volts, but that's not possible. 15, as soon as we get up to 20, it limits it to 20, unfortunately. So this won't be a 24-hour clock, but clearly we can do a 12-hour clock. We can get up to 12 volts, no problem. So that's the plan. So essentially I need to come up with some sort of precision voltage source that supplies this device with the time, and all should work well. Let's see what happens. This is the block diagram. Nothing too exciting here. The Arduino is controlling everything. Essentially, in a loop, it asks for the latest time from the real-time clock module. Then it calculates the voltage that it will need to output and commands the digital to analog converter over the SPI bus to output the voltage to the voltmeter. The only thing we have to concern ourselves with is the minute here on the voltmeter corresponds to 10 millivolts. So we need to make sure that the DAC has at least that resolution, and it also needs to output up to 12.9 volts. So it needs to be able to output a high voltage at that level. And what I've used here is an AD5501. This is a 12-bit DAC. It's in fact 12-bit over 30 volt range, which works out at 7.3 millivolts per bit, which is good enough. The Arduino here gets the latest time from the real-time clock modules, the DS3231 module with the battery backup, via the I2C interface here, these orange wires. Gets the current time, calculates what voltage is needed to be sent out based on the time and the various calibration parameters, and then it sends via the SPI bus here over to the digital to analog converter, which then outputs the appropriate voltage to feed the voltmeter. Most of the circuitry running on 5 volts, but for the output, the analog output, we need up to 12.59 volts for this 12-hour clock, which is 1259. And we produced that through this boost converter here, so it's a fairly cheap Chinese boost converter, and it's set at the moment to about 15 volts, which gives you some headroom. So that is fed into the digital analog converter's analog power supply. The rest of it is all 5 volt. So here's the finished board. I've got plenty of room inside the multimeter, so I just decided to stick these modules onto a bit of strip board. The power supply comes from this isolating 250 to 5 volt transformer, so you get 5 volt regulated output from that, which powers the circuit. So all that remains now is to wire this up to the mains up to the mains input for the meter, and wire the output here from the ADC, from the DAC rather, into the voltmeter. And here it is, packed up. 3.56 volt clock.